Hello and welcome to the show. This is Do All the Things. On today's episode, we're returning with the Sorado. I'm going to be doing some tweaks on its power supply because I might have gone a little overboard. Stay tuned. At some point in human history, I acquired this Sorado and it was broken and I rebuilt it. And over the past few years, it's been working great since I've repaired it. And I quite enjoy the sound of it. Now, I don't jam with it. I don't have to turn it up loud. Its sound when you start to turn it up loud and it breaks up is a bit weird. I don't know if that's how it's supposed to sound. At low and moderate volumes that I use it though, it's great. And it's got a lot of oomph. At some point, you might see a video of an 18-inch cab that I kind of retrofitted. And the low end, this thing chucked off. It would not stay sitting on the cab. But there is one thing, is that I kind of overdid the power supply when I rebuilt it. It's a little hard on the rectifier tubes. Now, for the last little while, I've been running it with this old reliable 5AR4 Ruby branded tube. And it has not complained. I've had this tube for 20 plus years. And it hasn't complained except for like one day when I went to turn on the amp. I believe this tube arced over and it popped a fuse. So I had to change the fuse and I think it wanted to arc over again. I can't remember if I popped another fuse. I replaced it with a tube that I'm surprised even works in this amp. It's a 5U4C Russian surplus or Soviet surplus, sorry. And it seems to be able to handle it, but it will also arc over. One day I made the mistake of putting a 5Y3 in here. That didn't end well. This thing, even though in theory it shouldn't have too much cap, I think it has too much cap. Let me explain. So here's the power supply circuit as I redesigned it. We have the 5AR4, we also have 4 007s, and we have a rectifier switch. That's gonna be the ground switch right here. I made it a rectifier switch. And then that goes to like the first set of capacitors, and then the standby, then the choke, and then the second set of capacitors, and then out to the rest of the power supply. So I did this thing where I took two double 100U CAN capacitors. I put them in series so that it can handle the 600 volts that this runs at. More accurately, 595 with diode, 575 with a 5AR4, and 565 with the 5U4C. So we can handle the voltage, but the capacitance, I did this hack where I used one half of the top cap for this half of the capacitance and the other half of the top cap for that half of the capacitance. And then I arbitrarily put in these balancing resistors, which do their job, but it's not perfectly balanced. I think this runs at 290 something. I can't remember. I'd have to test it again. But it's still a little bit hard on the recto tubes, and I don't want it to be. I want to solve that problem. There's a couple different ways you can solve that problem, but I kind of want to solve it correctly. I recently acquired this tool right here, a capacitance meter that we could use to measure our capacitances. I think it'll be handy. Surprised I've never had something like this before. Just very old school in my approach to how I work on these amps and haven't felt the need to get certain fancy tools. But that also means I will just change out capacitors for the sake of changing out capacitors just because like, oh, they're old, I should probably change them out. Now, if I use my bias probe here and plug it into the rectifier tube socket, this black wire is going to be on pin 8, which is connected to the capacitor stack. Now I make sure standby is turned off, and I make sure the rectifier is set to the tube rectifier, and then we just grab ground wherever and turn this on. And it's going to tell us how much capacitance the rectifier tube's encountering. Nice, but not nice. 69, 70 UF. Pretty much, which is technically over what it should be. I think the 5AR4 has been able to tolerate over the years, but this thing's definitely sparking up. I've had to use a startup procedure, and that is I set the rectifier over to the diodes, then I turn on the amp, and then once the amp is on, then I set the rectifier over to the tube. By absorbing that initial inrush current with the rectifiers, we avoid any spark over or misbehavior with the tubes. Maybe that 5Y3 would have survived if I initially did that, but I didn't. I put it in there and I turned the amp on. Now, interpreting the data sheets for the rectifier tubes has been a bit confusing to me because you see this says peak inverse voltage 1700 volts and you're like, oh, it can handle 1700 volts. No, it can't. Which is why I blew the 5Y3 because I thought I was going to understand it, but it can't. But we see here, oh, we have a chart that tells us the maximum. So we could do 600 volts, That's going to be the absolute maximum at maybe 100 and what is that? That's 25. Yeah, 125, 600 volts at 125 milliamps per plate. So that's, well, the plates flip back and forth. So we will say for all intents and purposes, that will be 125 total. But as you can see, as that current rises, maybe the voltage lowers. 475, that's 550, 25, 50, 65. So we're working right about here. Yeah, we're good for maybe not much more than 125 milliamps. That's fine. They don't really give us a maximum capacitance in this particular data sheet. Looks like a 5U4 should be able to handle it. Up to 250 milliamps. Oh, not really. At 600 volts, we can do right about here. Up to 125. So I could probably use a 5U4G as long as I don't crank it. These guys are not giving me a maximum capacitance either. 5U4GB might be 40UF, 40UF for typical operating characteristics. Well, this anecdote's falling apart right in front of my face, but some data sheets do seem to list maximum capacitance. Maybe there's more to it than that, because I have 64, it measures at 65U on another amp, and it has no problem. The 5U4G has no problem on that. The 5U4C works on that. 5AR4 works on that. Now it's only running at about 440 volts. No, less than that. So maybe it just doesn't work it as hard. But either way, the point I'm getting at is if I'm measuring 70 on an amp that's running at 600 volts, there's a chance that this is damaging and wearing out my rectifiers. They do not like it. Right now, I've just been running EL34s for fun. I don't know if they sound quite as fat as some of the other options. What do I have in here? An ECC83S by JJ. And yes, I have been running the 6U8As. I picked up some old ones. Here's a hit ray, which is kind of counter to the philosophy I had when I put a 6U8A in there. I've relaxed my bias against NOS a little bit more because some less common tubes are still widely available. So again, you might not be able to get exactly the tube you want if you particularly like a particular sound, but I know I can always get 6U8As. I have 3 of them now. So as creative as my design is, it's not quite working properly. We want 50, we're getting 70. Now, could that be because either or one of these stacks is seeing 100, or no, that's gonna be a total of 200U against a 100U. And then they get split, right? So you put them in series, this becomes a 50U, sure. And then this was supposed to be 100U, but 100U divided by 2 points. But maybe this thing's still behaving like you're putting a 50U on a 200U, and that's causing the difference. That's causing the lack of balance. Something similar happens with these caps. I tried testing these caps. You know, I'll take both these leads, hook them up to the negative of this cap. Don't even have balancing resistors. I tried messing around with the balancing resistor, it didn't make a difference. I'm gonna connect that to both leads here to kind of simulate the way I've coupled this all together. Grab our negative and grab one of our positives. 33. It should be 25, they're 50s, but we're getting 33. What happens if I disconnect one of these? Oh, look at that. Now it goes down to where it's supposed to be. Interesting. That said, I did this test with the standby off. So let us hook up here. So yeah, 70. What happens if I turn the standby on and hook up the other half of that cap? 72, 75. Now I always turn the amp on and off with the standby on. So maybe when this amp first fires up, it's seeing 75. And that's one of the other reasons why it's hard on the rectifier. I've stated many times, I don't believe in standbys. They're not necessary. Now, further expanding on this sentiment, if we look at the original Sun Sorado schematic, other than the fact that maybe the standby switch isn't implemented very well, we have 30 UF. Now, I guess we can expect that a 30 UF isn't gonna hurt a rectifier at all. But you know, when I initially redesigned the power supply on this, I called shenanigans on it because like 30 UF. Usually a good amplifier has at least 50, you know what I mean? Why is such a powerful, it's not really that powerful, bass amp have so little UF? And then it occurred to me recently, as I was actually editing that video, oh yeah, okay. Well, one of the rules of electronics is the more voltage you're working with, the less UF filtering you actually need. Most amplifiers that have 50 UF, they're maybe running at 480 volts. This thing's running at significantly more than that. Now I actually have a calculator that I put together. in Excel where, okay, so we have 2 preamp tubes, which it doesn't matter because I have to go here and I have to put in 4 because there's 2 elements in each preamp tube. And then based on some sort of math that I read on some website somewhere, 20 milliamps seems freaking excessive for the preamp section, but we'll roll with it. We actually know based on testing idle, it's more like 0.0037 milliamps. But we can put in 2 power tubes, 42 watts max because we are doing, typically KT88s. I have something for the screen grids here. We have 2 screen grids. They're gonna consume whatever the hell 8 is, estimating 4 watts, 10 milliamps. Okay, I'll take your word for it, bud. And then we're gonna bust it up to, okay, so say we use a 5AR4, 575 volts. And this down here is just heaters. Total milliamps ripping hard is 163. And then it spits out like, okay, I'm not gonna explain this calculator because I designed it years ago. It's based on math that I read online. It tells you how to calculate how much UF you need for a tube amplifier. It spits out 22U. Now, if I punch in numbers for some more conventional guitar amps, you might actually find it's higher. So if we have 3 preamp tubes with 6 elements, 4 tubes running at 25 watts each at maybe more conservative 480, that's a 100 watt amp right there, 4 screens. Oh, it wants 70U. Okay, so a 100 watt amp, 70U makes sense. What if we only have 2 tubes? Oh, now we're down to about 50U for a 50 watt amp. Wait, we forgot to compensate the screens. Wait, why do we have 36? Frick. Geez, if I don't have 36 preamp tubes, even a 50 watt amp only needs 25U. Oh boy, I got these numbers all wrong. 45, yeah, you see 500 watt heads all the time, they only need 50U. Okay, 2, 2, 2, 2, yeah. So you see these numbers make sense. 100U for a 100 watt amp, 50U for a 50 watt amp, running at normal amp voltages. A 600 volt amp doesn't need that much oof. And as you've seen, when I link these old caps together, I got 32 UF. So maybe, just maybe, this would be enough. These are capacitors that I pulled out of my JCM 800 because they are from 1988. It is 2024 right now. These capacitors are 36 years old, and the rule of thumb is if a capacitor is more than 30 years old, you kind of want to change it. But then I'm sure we have lots of stuff around that's 30 years old that still works fine. Maybe I didn't have to change these caps. Either way, my JCM 800 is the proud owner of fresh ass caps right now. And so is this one, but they're maybe too freaking big. So that's what I'm gonna do today. I'm gonna downscale our UFs. Now let me ask you again. Now what if we aren't cranking all the wattage? What if we say, we'll go like 1 watt for these guys, and we'll go, say we're turned down 20 watts. Very low power consumption. What happens if we're only running this amp at like 2 watts? We don't need, yeah. Let's do it. All that fuss and big talk about wrapping wire connections that I made, and now I'm in the position where I'm the next guy, and I gotta unwrap all these wire connections. At some point in my life, I got overly ambitious before I knew more about the design of these things with the whole bigger is better philosophy, and I purchased giant freaking caps, absolute units. I have a set of 500U caps. I have a set of 250U caps. I have these dual 100s, and it's like I have no practical application for them anymore because they're too damn big. In some cases, what happens is where you have a dual 50 that are tied together to make a 100, I'll just take one of these single 100s and put them in there just to use them up. I think that's one of these caps was in my JCM 800 at one point for that reason, just to use it up. Some of these poor old capacitors, they're getting reworked so much at this point. It's just like, dude, how fortunate I am that they're still hanging on. I do believe I have it all hooked up now. So you get quick ripping out all the wires. You sometimes forget where they all go back. So yeah, we got our recto switch here coming in from 2 different rectos. Then we got a bar going over to our standby, to which we have this little wire going out to this half of the capacitor. And then from the other standby goes over here to the choke. From the choke goes to the other half of the capacitor, out of frame. That other half, as prescribed by the schematic, goes out to the output transformer right here, goes out to this purple wire, which goes to the VRM, and our freaking dropping for the preamp. Right, yes. And then I just used the same balancing resistors. All right, I think we're good to fire this pupper back up. Don't see any reason why not. And we could turn it on, and well, if we switch over to one rectifier, we should be getting some measurements here. All right, what do you got here? 620. 620, top of the cap, 622. Other side, 621. Halfway through, 298. That's consistent with what we got before, which as you can see isn't quite 50%. Now I gotta cut power. Watch those numbers drop. Okay, I'm getting impatient. Okay, so now let's check what kind of capacitances we're dealing with. Capacitances. Okay, right here on the first half. 33 as predicted, standby on. 36. Okay, that's more where we want it to be. We're gonna go ahead and get our tubes loaded back into this thing. All right, so can we can't spark out the rectos? I don't want to spark out the rectos. I don't expect that the voltages in this amp would have changed by very much. So I don't think we need to rebias it. I maybe had it biased touch cold anyway, because the bias changes completely when you switch the rectifiers. So I had it so that it wouldn't go too hot when I go to the other one. So so far no red flags. I don't think a 5Y3, I'm not going to try putting a 5Y3 into this thing again because I'm pretty sure, what the, there it goes. But it happened so late in the game. It shouldn't have happened that late. If it was going to arc over, it would arc over like way sooner. I think maybe that AR4 is just too old to handle this amp. Like it gets away with it in like other amps of a lower voltage, but surprisingly, I don't think there's anything wrong with it though. Like it misbehaves once in a while, but okay, let's turn this back off, give it a time to cool down, try it with a different tube. Okay, meter's reading fully discharged now, pretty much. All right, let's try this tube. So this tube, I have seen it arc over before in this amp, but it's also, if I start it up with the rectifier or the diodes, it doesn't mind operating this amp after it's warmed up. So question is now, from a cold start with no diodes, will it arc over? I almost feel like I want to wear eye protection. I don't think these bulbs could physically explode, but still a little freaky. I've seen other stuff on amps explode, like switches. Here we go. Also to note, the fuse didn't blow when it arced. It's also worth noting, I don't know that this tube's technically rated for the amount of voltage that this amp runs at. So if we still have problems with our rectifiers, it might not be the capacitance fault. Okay, this one doesn't seem to care now. I think it would have freaked out by now if it was going to. Because yeah, this tube did protest a bit. Part of me wants to try it with a 5U4G, but there's no reason to. Well, there is a reason to. 5U4Gs are cheaper and easier to get. Like clearly this 5AR4 is not up to task anymore. Not in this amp. But then this tube works fine in here, so it's a moot point. Okay, well let's play test it anyway. So it's plugged into the cab right now. I'm not hearing any extra noise. Okay, let's bring this up. Is it possible it might actually be quieter with these? I have heard, I think somewhere, that having capacitors that are too big are not good. Like it might put a little bit more load on the circuit in such a way that might make it a bit noisier. Because one awesome thing about this amp is it's quiet as frig, bud. Like, trust me, nothing lets you get more into the zone than when you're playing an amp that doesn't hum at all. And it's just like the only sound that comes out of the speakers is the sound from your fingers. You can feel, you can hear, you touch the strings. I feel like this should be louder at 2 though. Turning it up, I do hear some noise. This is a noisy room though. I have some attenuation on that cab. How do I have this turned up to 5 right now? Now it's gonna have a honky tone because of the cab I'm plugged into. Oh, the entire room is rattling with those low notes though. She's chucking, she's moving her. Okay, let's give a little bit of onions here. Where's that feedback coming from? Oh boy. It's weird how not loud it is though right now. What's going on? I have this cab switched to 4 ohms, and when you do that, it makes it, there's 8 ohms worth of resistor in there. So it attenuates it. I'll flicker down to 8, plug her into the 8 ohm output. 2, 5. Ten. Is it just because it's bass? Is that rectifier dropping so much voltage? Oh, that rectifier might not be able to handle it. Well, there is one way to find out. Diodes, bud. No louder at 2. Not really any louder at 5. That's 7. Actually, yeah, I think it is just a touch louder with the diodes once I really bring it up. I won't know for sure until I plug it in over into the cab that I'm used to, like a 212 open back guitar cab loaded with Eminence Swamp Things. So it's 300 watts. We can't pop this no matter how much juice we chuck at it, but there's another thing we can try. Chuck her at the attenuator, bud. Attenuator's claim to fame is we start chucking sound into a fixed load. It puts us into a position where we could, you know, measure the output reasonably accurately. And I've said it once, I've said it a million times. I know this particular meter is accurate in the guitar frequency ranges. It's not just limited to 60 hertz. Right, 8 ohms of load, 8 ohms of tap. So at 2, where I often like to play it, we're getting 3 to 5 volts. 3 divided by 8 is that much, times 8, that's 3 watts. At 5 volts, we got 3.5 watts, so cool. Bring her up to 5. Got 6 to 10 volts. We'll just go 10 volts. Is that much times 10 volts is going to be about 12.5 watts, okay. So 5 is quarter output. Let's bring her up to 7. She starts to distort. I saw 14 to 18 volts. Let's try 15. 28 watts. Okay. Go all the way to 10. I'm not really seeing any more wattage. So we're only getting 30 watts out of this amp now? WTF, bud. Okay, let's switch our Recto. That Recto probably just can't handle the power draw of this amp. Yeah, we're still only 15, 16 volts at 7. 17 volts at 10. I tell you right now, it's not going to be 50 watts. No, it's 36 watts, bud. Okay, we need to resimulate previous conditions. So let's pull these EL34s. Let's hook up our bias probes. Let's get the KT88s. And this hit ray tube that I'm using is older. Let's put the Jan Phillips 6U8A back in. I think technically the 6U8A has a little bit more gain across the board than the 6AN8. I'm pretty sure the triode section does. The triode section is equivalent to like a 12AY7, whereas the original 6AN8 had like a 12AU7 triode section, so a little bit of a stronger phase inverter. Our upper bias range should be about 51. Let's start off at 49. Get wattage hooked back up. So far 2 looks about the same. All right, bring it up to 7. 17 to 15, 36 watts. Bring her to 10. Okay, yeah, we were hitting 19, 20. That's more like it. I know 20 volts at 8 ohms is about 50 watts, and that's where we max out. Like, it just... I think this amp might need other help. I think it's safe to say it's working consistently with the way it did before. And once again, I'm not sure if the modifications that I have done have decreased its power output. Like, this right here is not how we normally do things, even on the sun. Like, just a direct drive into there, eh? And a 270K. We could probably increase the gain of this stage with like a 470K. Maybe. That's normally driving a capacitor though. I did feel the need to add a blocking resistor because it was causing problems. And then that 100p made everything quiet. So, none of this matters. Not to me. What matters is that I don't want this guy popping rectos. And what matters is I mostly play this at lower moderate volume levels. It just has a really good tone hooked up to my SVT cabs. I'm not worried about this thing being loud. So it's like, I don't know if I care to sort that issue out. The hell was that? These pots, man. These pots and switches. They need a bit of help. But anyway, that's a bit of power supply redemption right there. Reducing the value of these capacitors down to more where they should be instead of what they were before. So I'm gonna leave it here for now. I hope you enjoyed this. If you did, stay tuned, because sometimes I like to change out the capacitors and amps and mess with their power supplies in ways that maybe people would say you shouldn't. Find out what I do next. Where are you going, bud? I don't know, over here somewhere. Stop button's up there. Yeah, I know.